Welcome to all. I am Dr. A. Simon Prabhu, Assistant Professor, Department of ECE, St. Joseph College of Engineering, Chennai. In this video, we are going to discuss about number system. In digital electronics, the first topic is a number system topic. In number system, what are the number system is that? How to convert one number system into other. This topic we are going to discuss in this video. It's a very easy. We know very well about number system. In number system, the following number system is used to represent the value. One is a decimal number system. It's a decimal. Another one is a binary number system. Next one is octal. The final one is hexadecimal. Hexadecimal. These four number systems are used to represent the number. It's a very well about the decimal number system, where first standard onwards, where mathematically all related numbers are equal to decimal only. Okay, we know very well. But each number system has some base value. Before we enter that, first you have to know about the base value of the each number system. For decimal, the base value should be 10. For binary, the base value should be 2. For octal, the base value should be 7. For hexadecimal, the base value should be 16. Okay, what is mean base value? Base value is nothing but that number of, for example, in decimal I have a base value of 10. They use 10 different digits to represent the decimal number system. There is a base value. It use 10 different digits to represent the decimal number. So how many different digits are used to represent that number system? That different digit number is called as a base value. For example, in decimal, the base value is at 10 here. The different digit is at 10 that are 0 to 9. 0, 1, 2, 3 up to 9. So 10 different digits are used here to represent the decimal number system. So the base value is here. In binary, only 2 different digits are used to represent the binary number. So its base value is so already we know 0 or 1. Only 2 different digits only used here to represent the binary. Binary value is represented either 0 or 1. Okay, so only 2 different digits only used. So it is called base value is 2. Here base value is 7 for octal. Here 7, sorry, base value is not 7, here 8. The base value of the octal is 8. So 0 to 7 different digits are used here to represent the octal. So totally 8 different digits are used to represent the octal number. Similarly, in hexadecimal, different 16 digits are used to represent the hexadecimal numbers. The different digits are 0, 1 up to 9. Next, A for 10 represents A, B, C, D, E, finally F. Okay, the A is belongs to the 10, the B is belongs to the 11, this is a 10, this is a 11, this is a 12, 13, 14, 15. But in hexadecimal, the A is represented as a, the 10 is represented as a, the 11 is represented as B, the 12 is represented as a C, the 13 is represented as a D, the 14 is represented as a E, the 15 is represented as a F. But in hexadecimal number system, we are using 16 different digit number to represent the hexadecimal value. So the base value is nothing but that number of different digits are used to represent that number system. Okay, that is a base value. Okay, I hope you understand what is the base value of the each number system. Next, we are going to discuss about number system conversion. In number system conversion, how to convert decimal into other number system. Decimal to other number system means, first we are going to discuss about how to convert decimal into binary, decimal into octal, decimal into hexadecimal. This we are going to discuss. Okay, first we are going to discuss decimal to other number system. In decimal to other number system, first we are going to discuss about decimal to binary. Okay, decimal to other number system. Decimal to other. Other means here either binary or octal or hexadecimal. Okay, first we are going to discuss about decimal to binary. Decimal to binary. Okay, what is the base value of the decimal? 10 here. What is the base value of binary? You know, 2 here. Okay, I consider one simple example here. 27. This is my decimal value. I am going to convert into binary. What is the binary value of this? Okay, this is a very easy method. So, first of all, I am going to divide the 27 by 2. We can ask the one question, why you are choosing 2 here? Okay, listen. The decimal is converted into binary. What is the base value of the binary here? 2 only. So I use number 2 to divide the given decimal value. Okay, for that only I am choosing here 2 because I am converted to decimal to binary. The base value of the binary is 2. So I am choosing 2 to divide this value. Okay, suppose you have to write the quotient here, remainder value here. So 27 divided by 2. Okay, so how many times will we get? 1. 13 is a quotient, remainder is a 1. Okay, again I am going to divide the 2. So 6 is a quotient, remainder is 1. Again I am going to divide by 2. 3 is a quotient, remainder is a 0. Again is a divided by 2. The quotient is a 1, remainder is a 1. Okay, again I am going to divide by 2 here, but 1 not divided by 2. So under this condition, you have to consider the quotient as a 0, this value considered as a remainder. Okay, so you have to continue this process till we get the 0 quotient. Till we get 0 quotient. Okay, suppose the quotient value should not divided by this value. Under this condition, the quotient will be considered as 0. This value will act as a remainder. Okay. Now I am going to write the binary number. For how to write the binary number means you have to start from bottom to top. You have to start from bottom to top. Okay. So bottom to top means this 1. Only I have to write the remainder. You don't write quotient. So remainder, you have to write the remainder, but you have to start from bottom to top. Okay, 1, 1, 0, 1, 1. This is my binary value for given decimal value. Okay, understand? Next, I am going to convert second decimal to octal. Decimal to octal. What is the base value of decimal? 10. The octal decimal, what is the base value of the octal? 8. Same I consider here, same example I consider for better understanding purpose. Okay, same I consider 27. There is a decimal value. I have to convert it into octal. that is a base value. Okay, so how to find this value? It's a very simple, same procedure I have to follow here, but only one difference is the values are divided by 2 here. Instead of 2, the values are divided by 8. Because I am going to convert decimal into octal. The base value of the octal here 8. So I have to divide the value by 8. Here I did decimal to binary conversion. In decimal to binary conversion, decimal value is converted into binary form. The base value of the binary form is 2. So I divided the value by 2. So here decimal to octal conversion. So I have to divide the value divided by 8. Okay, suppose 8 means what is the quotient here? Three times it become. Okay, so remainder also 3. Again I have to divide by 8. The 3 will not divide by 8. So already I told, suppose under this condition what I have to do? The quotient considers as 0, this value acts as a remainder. Is it correct? Okay, this is, so the quotient I get 0, so I have stopped the process. So I have to write the value from bottom to top. So what is the answer here? 33 is the answer. This is a decimal to octal. But in decimal to octal, we can easily to understand and also easy to find whether it is octal number or decimal number. In octal number, the each digit should lie between 0 to 7. The each digit should lie between 0 to 7. For example, you take the first digit here, the value is 3. So this lies between 0 to 7 only, is correct. The second digit also lies between 0 to 7. So it is also correct. The how many digits in the octal system? The all digits should lie between 0 to 7. That only the answer is correct. Suppose any value is like or any value is present more than 7. Okay, so you have to do some mistake here. The answer is wrong. So we can easily identify in octal number system, the each digit should lie between 0 to 7. This is a decimal to octal. Okay, I hope you understand the both how to make convert. Okay, third, I am going to explain decimal to hexadecimal. How to convert decimal to hexadecimal. Decimal to hexadecimal. What is the base value of decimal? 10. Hexadecimal is a 16. Okay. So the 27 divided by 16. 27 divided by 16. How many times here? Only one time it will come here. The quotient is a 1 only. Remainder how many will come? The 4. 4 plus 11 is a remainder. But you don't write 11 here. Already told in hexadecimal, A is represented 10. 10 can be represented as a A. The 11 can be represented as a B. 12 can be represented as a C. 13 can be represented as a D. 14 can be represented as a E. 15 can be represented as a F. So 10 can be represented as a A. 11 can be represented as a B. 12 can be represented as a C. 13 can be represented as a D. 14 can be represented as a E. The 15 can be represented as a F. Okay. So here 11 is a remainder here. Don't put 11 here because I am going to convert decimal into hexadecimal conversion. So the 11 can be represented as an hexadecimal is a B only. So I have to remainder it, I have to write in B. Okay, understand? Okay, next one is I am going to continue this process. Already I told this process will be continue till we get the zero value as a quotient. Zero value as quotient. Okay, so again I will divide by 60. The 1 will not divide by 60. So the quotient will be 0. This value will act as a remainder. Okay, so I have to write same procedure. I have to write from bottom to top. So the final answer is 1B is a final answer for given decimal value. For given decimal value. For 27 is the decimal value. If you convert it into hexadecimal, 1B. Okay, I hope you better clarification. You get better clarification in decimal to other form conversion. How to convert decimal to binary, how to convert decimal into octal, how to convert decimal into hexadecimal. Okay, next we are going to discuss binary to other form. Binary to other form. Binary to other form. In binary to other form, first we are going to discuss about binary to decimal. Binary to decimal. Okay. For example, I consider one binary number. Very simple binary number I will take. So 1110. 1110. This is my binary value. How to convert it into decimal? Okay, how to convert? In binary value, two number, the binary value generally classified into two categories. One is a weighted number, non-weighted. Okay, weighted number means the each digit is allotted with some weighted value. That's all are weighted code value. Non-weighted code value, in each digit does not contain any weighted value. That is a non-weighted code. For example, XS3, gray code. These all are non-weighted code. For weighted code, it's a binary, BCD code. These all are weighted code. Because each digit has some weighted value. But by gray code does not have weighted for each digit. So it's non-weighted code. It under the non-weighted code will come. So the binary is a weighted code only. So each digit has some weight value. The weight value allocation should be like this. For example, I consider one example here, 1110. This is my binary value. Okay, how the weighted value is present in this given binary value means the most left hand side bit. The most left hand side bit, this is the most left hand side bit. This is called as an MSB bit. In binary system, the most left hand side bit is called MSB bit. The most right hand side bit is called LSB. LSB means least significant bit. MSB means most significant bit. Okay. In LSB bit, the weighted value starts from the LSB to MSB. First you have to give the weight value for the LSB. Here the weight value is a 2 power 0. The first LSB. Next you have to move from right to left. Okay. The weighted value next to 2 power 1 for this digit. 2 power 2 for this digit. 2 power 3 for this digit. The weighted value allocation is going on. How many digits will be present here? The weighted value allocation is going on. How many digits will be present here? Okay. So here 4 digits only present here. So my allotted weighted value like this. Okay. How to convert my binary to decimal means it's a very simple or very easy way. The each digit are multiply with its weighted value and make sum, then we get the decimal. Okay. If we do, we can easy to understand. Okay, listen here. The first digit is the binary value is what is 0. Its weighted value is 2 power 0. The each digit is multiplied with weighted value and make sum. Okay. So 2 power 0 is a 1. 1 into 0, 0 only. So the second digit is 1. Its weighted value is at 2 power 1. So 1 into 2 power 1, so 2 only. Similarly, here 1 into 2 power 4, 2 power 2 is a 2 power 4, 2 power 4 into 1, 4. This here 1 into 2 power 3, 2 power 3 means 8, so you get 1 into 8, 8. If we add 14, 8 plus 4, 12, 12 plus 2, 14. Okay, so the decimal value is 14. Okay, this is a binary to decimal conversion. Okay, you understand how to do the binary to decimal conversion. Okay, it's nothing but the binary digit is a multiply with is a weighted value and make sum, then we get the final decimal value. This is a binary to decimal conversion. Next we are going to discuss binary to octet. Binary to octet. How to convert binary to octet. Binary into octet. Okay, it's a very easy. Okay, binary into octet. Same example I considered here. 1, 1, 1, 0. The base value of octet is 8 here. The base value of octet is 8. So same procedure you have to follow in binary to octal system conversion. The given binary value 210, the octal value you have to convert. In binary to decimal, what we did, we take one binary value. Each binary digits allotted with some weighted value. Each digit multiplied with weighted value and make sum. Then we get a decimal value. Okay. Similarly here in binary to octal, binary to octal conversion. Okay, binary to decimal we know very well. In binary to octal conversion is very easy. Before do this conversion, first you have to know about how to represent the octal number in the binary form. Okay, for example, octal value starts from 0 to 7. 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, you have to represent in binary form. How to represent in binary form? It's a very easy. You do not memorize this. We can easy to keep in our mind that I will tell you one shortcut. One, you have to represent the octal value in the binary form 3 digit only. Okay, so I put 1, 2, 4. 1, 2, 4 format. For 0, I have to disable the all digit, then only I get 0. Okay, for 1 to 1, I have to enable 1 only, disable the 2, disable the 4, then only I get 1. For 2, I have to enable the 2 only, I have to disable the 4 and 1. Similarly, for 3, I have to disable the 4, I have to enable the 2 and 1. For 4, I have to enable the 4, disable the remaining 2 and 1. Next 5. I have to enable the 4 and 1, disable the 2. Then only we get 4 plus 1, 5. For 6, I have to enable the 4 and 2, disable the 1. Next is 7. I have to disable, will not disable anything, you have to enable the all. 4, 4, 2, 1. Okay, then only we get sum. Okay, is it correct? So this is a, you have to keep it in mind. What is the binary value for each octal value? Okay. Now we are given problem is you have to convert the given binary value into octal. So how to convert means is very simple. You have to make a group. Each group consists 3 bit. Each group consists 3 bit. Okay, how to make group here? So already in binary value, the most right hand side bit is called LSB bit. The most left hand side bit is called MSB bit. Okay, this is a LSB, this is a MSB. Okay, you have to start our grouping from LSB only. Okay, first 3 digit I consider as a 1 group. The next 3 digit I consider as another group. But in second group only 1 digit is there. Okay, so we can append the remaining digit as a 0. Okay, for how many digits I have to needed here? In second group only 1 digit will be there. Each group consists 3 digits. So only 1 digit will be there. So I need 2 digits. So I add 2 0. I append 2 0. Okay. So this first 3 digits is a group 1. This how to represent this octal value will be very well. Already we explained here. Double 1 0. Double 1 0 means is a double 1 0. Is a double 1 0. Okay. So this is 6. Double 0 1. Double 0 1. We can be represented in octal 1. Okay, this is the octal 1. Okay, this is a 1. Okay, and therefore this answer is 1 6. Okay, understand how to convert binary into octal. Next I am going to explain binary to hexadecimal. Binary to hexadecimal. It's also very easy. But in hexadecimal, how many digits is that? The hexadecimals can be represented by 16 different digits. Is it correct? The 16 different digits is hexadecimal. In hexadecimal, 16 different digits are used. One is a 0, another one is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will not come here. A, B, C, D, E, F. Okay. These are 0 to F. You have to represent each hexadecimal in the binary form. How to represent? 1, 2, 4, 8 form that you have to use. Because in octal, each octal digits are represented in the 3 digits. But in hexadecimal, each hexadecimal value represented in the 4 digits. So I have used 1, 2, 4, 8 format. Okay, understand? Okay, so for 0, you have to disable the odd digit, then only we get the 0. For 1, you have to enable this 1 only. You have to disable the remaining 3 digits. For 2, you have to enable this, the remaining are 0. For 3, I have to enable the 2 and 1, the remaining are 0. Okay, for 4, you have to enable the 4 only, the remaining are 0. For 5, I have to enable the 4 and 1. For 6, I have to enable the 4 and 2. For 7, I have to enable the 4 to 1. For 8, I have to enable the 1 0 0 0. For 9, I have to enable 8 and 1. For 10, A means 10. So 8 plus 2, 10. I enable 8 and 2, then we get 10 as a A. Next one is B means 11. So 8, 2, 1. We get 11. 12 means C. So 8 and 4 we have to enable. For D, 8, 4, 13. 8, 4 plus 12, 12 plus 1, 13. For E, we get 8, 4, 12 plus 2, 14. So 2 I have to enable, this will be 0. For F, we have to enable on. Okay, this is a hexadecimal to binary conversion. Okay, so same example I consider here for better understanding purpose. For hexadecimal to binary, binary to hexadecimal, binary to hexadecimal, binary to hexadecimal. Here base value is 16. So what is the binary value? 1110. This is my binary value. I have to find the hexadecimal. What is the hexadecimal for this? Okay, you have to make a group. Similarly, binary to octal conversion. But here I have to make a group. Each group consists 4 digits instead of 3 digits. In binary to octal conversion, each group consists 3 digits. Yes, binary to hexadecimal conversion, each group consists 4 digits. There is a major difference between them. Okay, so I have to make group from left to right. Okay, sorry, LSB to MSB. Okay, MSB is most left hand side bit, LSB is most right hand side bit. Okay, this is a LSB bit, this is a MSB bit. You have to start to group from here. So each group consists 4 digits. Okay, so what is the hexadecimal value for this? 1110. 1110. This is a 1110. It's a E. So E is my hexadecimal value. So for this binary, the answer is E. Okay. I hope you understand number system concept, and also I have explained how to convert decimal to other form conversion, binary to other form conversion. I hope you understand well. Thank you.